Hi everybody, it's Miss Austin and I'm going to be doing the Unit 5 Lesson 3 practice problems. Number 1, here's a graph of f and a graph of g. Express g in terms of f using function notation. So I'm expressing g, this one's g. I just need to go over it for myself. So to get g, I take f, and I'll use this point that they've identified for me, and I'm going to shift it 1, 2, 3 to the left. So g of x is f. Now, if you want to shift a graph left or right, the number goes in with the x opposite of what you would think. So to the left, I'm going to go plus 3. G of x equals f of x plus 3. Tyler leaves his house at 7 a.m. to go to school. He walks for 20 minutes until he reaches the school, 1 mile from his house. The function d gives the distance d of t in miles of Tyler from his house t minutes after 7 a.m. So the important thing here is let's make sure we know t, right? That's my input, it's time in minutes, and then my output is how far he is from his house. Explain what d of 5 equals 0.25 means. So there's my input, time. So 5 minutes, which would be what time? It's 7:05 a.m. This is how far he is away from his house. He is 0.25 miles from home. On snowy days, Tyler has a 2-hour delay. Delayed start time, 120 minutes. I did not say that. On snowy days, Tyler's school has a 2-hour delayed start time, 120 minutes. The function s gives Tyler's distance s of t in miles from home, t minutes after 7 a.m. with a 120-minute delayed start time. If d of 5 equals 0.25, then what is the corresponding point on the function s? Well, it's going to be shifted 120 minutes further in time. So s of 125 equals 0.25. He would still be a quarter of a mile. It would just be exactly 2 hours later after that. Write an expression for s in terms of d. So s of t is equal to d. It's been shifted 120 minutes into the future, so to the right. So it's going to be time minus 120, opposite of what I would think. A new function n is defined as n of t equals d of t plus 60. Explain what this means in terms of Tyler's distance from school. So plus 60 would mean I went left 60, back in time. So what would that mean? He must have left for school an hour earlier. So he started his walk 1 hour earlier, or you could say 60 minutes. Big idea here, to shift a graph horizontally, left or right, the number goes in with the input, opposite of what you would think. All right, number 3, technology required. It says here are the data for the population F in thousands of a city D decades after 1960, along with the graph of a function given by f of d equals 25 times 1.19 to the d power. Elena thinks that shifting the graph of f up by 50 will match the data. So here's the graph. This is f of d, and there's the data. Elena thinks just by shifting that up it'll work. And Han thinks that shifting it by 60, up by 60, and then right 1 will match. What functions define Elena and Han's graphs? Well, Elena's, she thinks that she's going to use this, but shift it up 50. How do you move a graph up or down? You literally put this number at the end. Up is plus. So Elena's would be f of d equals 25 times 1.19 to the d plus 50. Han thinks that he's going to shift it up 60, which I'm going to do that, but then right 1. Now to move a graph right, it's got to go in with the input, which is the decades, and opposite of what you would think. So if you want to move it right, you're going to have a -1. So this is 25 times 1.19. Left or right, it's got to be in with the input. So it's going to be D minus 1, and then plus 60 at the end will shift it up 60. Use graphing technology to graph Elena and Hans' proposed functions. So I am going to open up Desmos here. Hopefully this will help. And let's see. They want me to do what? Use a graphing technology to graph. I guess we're going to have to kind of, first let me get the window the same. The x-axis is from 0 to 6. It's not going to let me do this. Oh, I'm not on mouse. Miss Austin doesn't know what's going on. 0 to 6. And then the y-axis is from 0 to 150, going by 25s. There. Except I don't really want this. I want this to go by ones. Okay, so hopefully this will help. So we're supposed to be graphing Elena and Hans. So let's look. 25 times 1.19 to the, we can't use D in Desmos, we have to use X, and then plus 50. And then Hans is 25 times 1.19 to the X minus 1 plus 60. Hard thing is we don't have the data here. So I'm going to kind of look back in my book, and I notice the first point is below 75. It's like 4 and barely over 100. Let's see. 4. This one's way above. I'm going to look in the book. What's another one? 1 and barely over 75. 1 and barely over, yeah. I mean, look how far Hans is way above 75. Let me look at 2. 2. Yeah, I think in general, the red graph is closer to the data. Now it's a little bit difficult because we have to look in the book and look at the points. But in general, Elena's graph is a better fit. So let me go back to this. Which graph do you think fits the data better? Elena's is closer to the data points. I'm just going to say here we did this on Desmos. All right, number 4. Here is a graph of y equals f of x plus 2 minus 1 for a function f. Sketch the graph of y equals f of x. So this has been shifted left 2 and down 1. So I want to go back to the original graph, so that would mean I need to shift it right 2 up 1, because it's already been transformed. This is the transformation. So I want to undo this stuff. So I want to go right 2 and up 1. So let's see. I'm going to try to 1, 2, 3, 4. I'm just making my own here. So right 2, so 1, 2, up 1. Let's pick another good point. What do we think this is at? Use a pencil here. I'm just going to get this point right here. Maybe right there. So right 2, boom, boom, up 1. And this, in general, right 2, up 1. All right, moving on. Describe how to transform the graph of f to the graph of g using only translations. That's left, right, up, down. So how do I get f to g? Let me pick this point. And that would correspond to this point. So it looks like I have to go left 2, down 2. Left 2, down 2. Okay, then they say, now can you do it with a reflection and a translation? I'm going to get some patty paper here. Thought I had it already drawn. I guess I'm starting over. So they want me to get this with a reflection. So I'm going to try the y-axis. And I'm going to emphasize that point right there. So I'm going to reflect it across the y. Why did I decide that? I don't know. I just decided to try it. You could try the x. I'm going to reflect it across the y. Get that lined up. And now, how am I going to get this to this? It looks like I'm going to have to shift it left 2 and down 2. Let's try. Left 2 and down 2. Okay, so I'm going to reflect across the y-axis. Then I'm going to go, oh, it was right 2. Right 2, down 2. Which kind of makes sense, because once this was left 2, down 2, and if I started over there, it's now right 2, down 2. There's probably other ways you could do that. Number 6, last one. Here's a graph of the function f and a graph of function g. Express g in terms of f using function notation. So I can see this point right here is at 0, 1, and now that point is at, it's been shifted down how many? It was here, and it's down 1, 2, 3. So g of x is f of x. To shift a graph down, you just throw it at the end, and down means minus 3. Okay, I hope that helps, and I'll see you soon.